track, rectangular jogging track around the park. The track has a length of 40 meters. Okay, so I need to picture these things in my mind, so I need to make sure I'm doing the right thing. So I'm going to do the rectangular figure myself. And it says here that it has a length of 40 meters. This right here is my length. Okay, 40 meters. And a width of 32 meters. So this is the 32 meters, okay? If it will cost the city $23 per meter to build a track, what will the total cost be? So we're talking about the area, the inside, or we're talking about all of the around, all of the outside? It's talking about the outside, okay? So it's the perimeter, okay? So this is the outside still, and this is still the outside, okay? We are not worrying about what's inside, okay? That would be the area, and we're not talking about area. We're talking about just the outside because it's the length of a jogging track, okay? So let's see. Let's look at the question again. If it will cost the city $23 per meter to build a track, what will the total cost be? So we need to know the total cost. But what is the first thing that we need to figure out then? We know it's $23 per meter, okay? But I still need to figure out what. So first things first, if I need to know how much they will pay for all of the around, okay? I need to know what's the length, okay? So here we go, we have 40 plus 40, that's 80. And then 32 times 2, okay? We could have done here 40 times 2, okay? It's the same thing, gives us 80. This is a 4, and this is a 6. So we know that the length is 80, and the width is 64, okay? So 80 plus 64, that's a 4, and this is a 14. So we know now that the whole perimeter, the all around, is 144 meters. And we know that it's going to be $23 per meter. What are we going to do with those? We're going to add, multiply, divide, subtract. We're going to multiply because we know it's $23 per meter. And whenever we say the word per meter, right here, per, we do multiplication. So we have multiplication, 4 times 3. Now, let me show you this. Remind you of something, people. Whenever we are multiplying by 2 digits, remember we first start with this, and then we go on with this. Okay? Don't forget, people. So I'm going to do it here on the side. That way you guys can see that as still as little notes. So 144 times 23. So we start with the blue, right? 3 times 4 times 4 times 1. So 3 times 4 is 12. We carry the 1. Another 3 times 4 is 12, but we have a 1, so that's a 3, and we carry the 1. 3 times 1 is 3, plus 1 is 4. We always skip, when we're going to for the second number, we always skip this spot right here, and that's a 2 times 4 is 8, 2 times 4 is 8, and 2 times 1 is 2. So now we add. That's a 2, that's an 11, that is a 13, and that is a 3. So our answer is C, $3,312. 6B. For the fall festival, Mrs. Delgado ordered 16 cases of caramel corn with 24 boxes in each case. There were 319 boxes of caramel corn sold at the festival. How many boxes of caramel corn were not sold at the fall festival? So we have quite a few things here. We have 16 cases, 24 boxes each, and we have 319 boxes sold. But I don't have the total. It says 319 boxes of caramel were sold at the festival. but it doesn't say how many boxes they had in total. But look at this. We have a case and we have each. That makes me think of what? What can I use here? Yep, we can use the GET, the get. Because a case, that makes me think of a group. So that's 16 groups. And this one has each, so 24 in each. And yes, we're missing the total. And whenever we're looking for the G, we would divide. Whenever we're looking for the E, we would divide. But whenever we're looking for the total, we would multiply. So in this case, we're going to multiply so that we can find out the total of boxes. So we have a 24 times 16. The 6 times 4 equals 24. We carry the 2. Now 6 times 2 equals 12 plus 2 equals 14. Now let's do it in a different color. Now we're doing the ones. 1 times 4 equals 4. And 1 times 2 equals 2. Now we add them. It's a 4, an 8, and a 3. So the total of boxes were 384. Now what do we need to do? Are we done? Here's the answer. Are we done? Whenever we have doubts if we're done or not, let's look at the question again, okay? It says how many boxes of caramel were not sold. So here's the one that they sold, 319, but we have in total 384. So we're going to subtract those so that we can find the difference, so that we can find how many were sold. So we have 384 minus 319. 4 minus 9. So we need to regroup from the 8. Becomes a 7. This becomes a 14. 14 minus 9, 5. 7 minus 1, 3 minus 3 equals 0. So 65. 65 boxes were not sold. If you're done with that, let's look for page 35, please. Let's head out to page 35. And it looks very similar to what we did yesterday, although we're not going to be using the words we used yesterday. Yesterday we used acute, obtuse, and right. Today we're not using acute. Today we're not using obtuse. Today we're not using right triangle. All right, so just like yesterday, we need to move on because we were always run out of time in math. Okay, so we have triangle. This is a triangle. What type of triangle is this? What name of it? What's the name of this triangle? Anybody? B. Triangle TUV is, and what? What type of triangle? Nope, we're not using acute anymore. We're not using obtuse anymore. We're using other words. Look, I'm going to give you a hint. And here's the hint. This side is equal to this side and equal to this side. This angle is equal to this angle and to this angle. So all sides and angles are congruent. What do we call a triangle where all sides and all angles are equal, are congruent? What kind of triangle is it? An equilateral triangle, people. And let's make these little notes. Equi means equal, okay? And lateral, we know it's sides. So triangle TUV is an equilateral triangle because all sides and angles are congruent, equal. And on number 1, of course, you need to do another one, okay? You can draw it however you want. These ones cannot look very different, okay? They all need to look equal, okay? Because remember, the sides need to be equal and the angles need to be equal, okay? So something like that. And so triangle DOG is an equilateral triangle because all of its sides and angles are equal. Notice how I worded it differently, but it means the same. I'm going to move on to B. If you guys did not finish 1, it's okay. I'll take a picture of it and send it to you guys, okay? Let's look at B. Everyone, let's focus on B. What's the name of this triangle? The name, not the type, the name, QSR. So triangle QSR is N, and I'm going to give you clues. This side is equal to this side, but it's not equal to this side. And this side is 1, but these two are the same. So, what kind of triangles got two sides that are the same and two angles that are the same? It starts with the isosceles. Isosceles triangle because it has two sides and angles that are the same. It's an isosceles acute triangle. And for two, I know you're supposed to draw your own, but I'm going to give you another example of mine because we don't have a lot of time and because I also want you guys to look that they don't have to look the same. So I'm going to draw mine. It's going to be there. And I'm going to label it. This side is congruent to this side, but it's not congruent to this side. So it's got two sides that are the same. Now, this angle is congruent to this angle, but it's not congruent to this. So it's got only two congruent sides, congruent angles. So this one I'm going to call it triangle PIG. So triangle PIG is an isosceles because it has two congruent sides and angles. Let me know by showing me thumbs up if you guys are done with that. That way I can move on to letter C, please. All right, great. Now this one. Let's start with the name again. Triangle what? WXY. And let's label it. Okay, this angle, this side is not the same as this side. And it's not the same as this side. So no sides are the same. Let's look at the angles. This angle is short, this angle is big, and this angle is medium. They're also all different. So what kind of triangle has all sides different and all angles different? So triangle WXY is and it starts with the S, scalene triangle because none of its sides and angles are congruent. And you guys finish number 3 on your own later on, whenever you have a chance. This is page 40. Number 1, it's doing what we're supposed to be working on this week, subtraction and addition of decimals. All right, so let's start with 50 and 731 thousandths. So 50 and 731 thousandths minus 29 and notice how I did align my decimal points correctly, 97 hundredths. Yes, you can put a ghost 0 there if you want. And let's start. 1 minus 0 equals 1. 3 minus 7 equals what? So this guy becomes a 6. This guy becomes a 13. 13 minus 7 equals 6. 6 minus 9, this guy has a 0. So we regroup further. This guy becomes a 4. This guy becomes a 9. And this guy became a 16. 16 minus 9 equals 7. Great job. Don't forget the decimal point. Super aligned. 9 minus 9 equals 0. And 4 minus 2 equals 2. So my answer is 20 and 761 thousandths. Clue word here is align. Let's head out to page 49. We're going to be doing subtractions, but we're going to be sketching. And we're going to start with 4 ones and 276 thousandths plus 12 hundredths. And of course, yes, you can put the ghost there. All right, we need to sketch here. We have 4 ones in the ones place. Okay, so that's 1, 2, 3, and 4. We have 2 tenths in the tenths place. We have 7 hundredths and we have 6,000. All right, the next one we need to sketch them. We have nothing in the ones place. We have a 1 in the tenths place, and we have 2 hundredths. We are adding, so we're not worrying so much about many other things. Okay, so adding here in this area is where we combine things. Okay, So we just need to bring them down. There's nothing to do here, so we bring this down. So we have 6. Here we have a little 7. So let's put a little 7 there and a 2. We have 7 plus 2 equals 9. So that's a 9. And here we have 2 plus 1 equals 3. And here we have nothing to add with, so we just have the 4. So our answer is 4 and 396,000. B, 1 and 5/10 plus 642,000. Yes, we can put the 2 goals. So let's do this. Let's sketch. We have a 1. We have 5/10 and nothing else. We have 0 ones. We have 6/10, 4 hundreds, and 2 thousands. We are adding, so we just combined. So bring this down. We have 2 thousands. We have 4 hundreds. And here we have 5 plus 6. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can I put an 11 here? We can't. So we need to regroup. So we get 10 of these guys. And we bring them up over here. So they become a 1. Okay, so we slash them over. And so this guy only becomes a 1. Now here we have 2, so we have a 2. So we have 2 and 142,000. I am going to give you the numbers for C, but we're not going to work on it because we don't have a lot of time. If we have time, we can come back to it. The numbers for C is going to be 1 and 37 hundredths plus 1 and 83 hundredths. So you guys work on that one on your own, okay? If we have time, we'll come back to it right now. We need to work on a couple of them with subtraction. So D, we're going to do 2 and 7,500 hundredths and 1 and 2/10. This one is subtracting, people. So let's pay close attention to it. Let's sketch. And of course, you can put a 0 there. Okay, let's sketch. We have 2 7/10 and 5 1s. Let's sketch the subtrahend. We have 1. We have 2 and nothing else. Nothing here, so don't worry about that one. We're just bringing this one down and down. So we have 5. So we put a 5. We're subtracting, so we're going to do subtracting with red. We're canceling this one, cancel that one, cancel this one, cancel that one. So how many do we have left? We have 1, 2, 3, 4, 5. So that's a 5. So that's a 5. And this one's we cancel 1 as well. So we only have 1 left. So that's a 1. So our answer is 1 and 55 hundredths. Let's look at E. We have a 2 minus 4/10. It's not a biggie. Let's put down the ghost 0. And let's head out and sketch. So we have 2 1s and we have 4/10. Can we take away 4/10 from anything here? There's nothing in the 10, so we need to regroup, people. Okay, this guy is going to come this way. So it's 10. It becomes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we cancel. Cancel 1, 1, 2, 2, 3, 3, 4, 4. And we have 1, 2, 3, 4, 5, 6 left. And this one, there's nothing to, but we only have 1 left over. So that's a 1. So that's a 1. So our answer is 1.6. Questions? On F, we're going to regroup 2 times. So we have a 4 minus 1800. 4 minus 1800. And of course, we can put ghost zeros there. And now we regroup. So we have 4 1s, 1/10, and 800. There's nothing to take away from. So we will need to regroup. We can't regroup from this guy. So now we have to regroup from this guy. So this one comes over here in the form of 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But this guy needs help still. So we're going to get one of these guys and bring it here in the form of 10. 2, 3, 4, 5, 7, 8, 9, 10. So now we have 10 minus 8. Cancel each other. We only have 2 left. So that's a 2. Here we cancel this one and this one. So we only have 1, 2, 3, 4, 5, 6, 7, 8. So we have an 8. And this guy is no longer there, but there's nothing to take away from them anymore. So we just have 3. So that's a 3. So the answer is 3 and 82 hundredths.